What is a transition function in reinforcement learning? Imagine you're playing a game where your character moves around a world. Every move you make changes where you are. But what if those moves sometimes don't go exactly as planned? That's where the idea of a transition function comes in. In reinforcement learning, an agent interacts with an environment by taking actions. The environment responds by changing its state, which is like the current situation or position of the agent. The transition function is what tells us how likely it is to go from one state to another after an action. Think of it as a rulebook that shows the possible next states and their chances. For example, if you tell a robot to move forward, it might usually go straight ahead. But sometimes, it might slip or bump into something, ending up in a different spot. The transition function captures this uncertainty by giving probabilities for each possible next state. It's like rolling a die where each face has a different chance of landing face up. This function is a key part of what's called a Markov decision process, which is a way to model decision-making where the future depends only on the current situation and the action taken. The transition function helps the agent predict what might happen next, so it can plan its moves better. Some reinforcement learning methods assume the transition function is known beforehand, which is called model-based learning. These agents can simulate future scenarios to decide what to do. Other methods don't know the transition details and learn purely from experience, called model-free learning. Knowing the transition function is like having a map of how the environment reacts to your actions. It helps the agent make smarter choices by understanding the environment's rules. This idea isn't just for simple games. It's used in robotics, autonomous vehicles, and even in AI tools like ChatGPT that learn from interactions. In the end, the transition function is what connects actions to outcomes, showing how the environment responds and changing the game. It's a fundamental part of how agents learn to navigate and succeed in their worlds.